July 14th, 2026, Eastern Ukraine, a sector the military designates as Priority Zone 7. A Ukrainian bomber drone, roughly the size of a suitcase with a 10-kilogram payload cradle, lifts off from a concealed launch point 3 kilometers behind the contact line. No shaped charge, no fragmentation submunitions. It carries a robot. Inside the forward operations cell, 20 kilometers to the rear, 5 operators track the flight on 3 separate screens. One runs the delivery drone. One runs a small FPV craft circling 600 meters overhead. The third monitors a feed from a recon drone that has been watching the target trench for the past 40 minutes. The UGV, the unmanned ground vehicle locked in the bomber's payload bay, is roughly the size of a carry-on bag. It weighs 14 kilograms. It can navigate terrain, hold a position, detonate obstacles, or deliver direct fire. The bomber drone descends. The release mechanism engages at 40 meters altitude. A cushioned drop. The robot lands upright in the trench. The assault has begun. Not a single Ukrainian soldier has left cover. What you just saw is real, not a simulation, not a concept demonstration from a defense exhibition. Channel 4's documentary team filmed this exact sequence in Ukraine in late June and early July 2026, the first confirmed media footage of a working drone-to-ground robot delivery in active combat operations. The drone was real, the robot was real, the trench was real. And according to Ukrainian commanders on camera, it has already changed the casualty math in specific sector operations. This breakdown covers the full technical picture, the delivery system, and the ground vehicle it carries, the command and control architecture, the actual engagement timeline, and what NATO defense ministries are now quietly debating as this doctrine moves from laboratory to active front line. Because the question this technology forces is the same one defense planners have been avoiding for 3 years. If an unmanned ground vehicle can breach a fortified trench before any human soldier approaches, what is dismounted infantry assault actually for? The implications reach well beyond Ukraine. We start with the breach problem, the one constraint that has never changed. In warfare, one tactical reality has stayed constant. At some point, human soldiers must cross exposed ground. Suppression reduces enemy fire. Artillery preparation destroys obstacles. Smoke limits visibility. But the moment of breach, when troops leave covered positions and move through the contested zone into the objective, is when casualties concentrate. Every tactical innovation since the Somme has tried to compress that exposure window. None has eliminated it. Until mid-2026, the best available approach was fire and movement combined with smoke, FPV drone overwatch, and as much pre-clearance by munition strikes as possible. The casualty rate during a breach on a well-fortified Russian trench position, the kind with overhead cover of 2 to 3 logs deep, firing slits, and pre-sighted machine gun arcs, was significant. Ukrainian field commanders have described typical assault costs through open-source interviews. A standard operation to clear and hold a prepared Russian position required 15 to 20 personnel in the assault element, with substantial risk concentrated in the first 40 seconds of the breach. The drone UGV packet replaces the breach team. If you find that worth staying for, subscribe. We break down every major unmanned warfare development as it reaches the front line. Here is what the 3-asset packet actually looks like in the operations documented by Channel 4 and corroborated by Ukrainian military statements in June and July 2026. 3 assets, 5 operators. 1 remote control cell positioned 20 kilometers from the contact line. Asset 1. A reconnaissance drone, typically a modified commercial quadcopter fitted with thermal imaging, orbiting the target zone for 30 to 60 minutes before the operation begins. It maps the trench layout, identifies firing positions, and confirms the presence and location of Russian personnel. This drone carries no weapons. Its operator is building a targeting solution in real time, sharing the feed to a central display in the operations cell. Asset 2. The delivery drone. Ukrainian engineers adapted this from the Bober-class bomber airframe. A fixed-wing design with a 10 to 15 kilogram payload capacity, stable low-altitude flight characteristics, and a release mechanism originally designed for munitions delivery. The payload bay was modified to carry a UGV in a padded cradle. The release system triggers at a calculated altitude based on drop cushioning specifications, typically between 30 and 60 meters, to ensure the ground vehicle survives the landing with systems intact. Asset 3. The FPV Overwatch Drone. Once the UGV is on the ground, the FPV operator provides direct observation of the vehicle's operating environment and can engage any Russian personnel who approach or attempt to neutralize it. Standard FPV doctrine, except now the FPV is protecting a robot, not accompanying human soldiers. The UGV itself. Ukrainian military sources have not released full specifications, but open-source analysis of the Channel 4 footage and statements from Ukrainian engineers place the performance parameters in a consistent range. Weight, 12 to 16 kilograms at operational load. Ground clearance, approximately 12 centimeters, sufficient for standard trench terrain. Drive system, tracked, for obstacle crossing and stability on loose soil. Payload, variable depending on mission profile. A shaped charge for IED detonation, a direct fire module for engagement, or sensor-only configuration for scouting. And the control link. This is the technical crux of the entire system. One detail that stayed with me when reviewing the Channel 4 footage and the subsequent commentary from defense analysts. The fiber-optic cable is not an afterthought. It is the design requirement around which the entire UGV control architecture was built. Because the Russians know exactly what happened to radio-linked FPV drones in 2024 and early 2025, their electronic warfare units fielded wideband jammers that could disrupt GPS navigation and video links across substantial portions of the front. Ukraine answered with fiber-optic FPV drones. The same logic now governs the ground vehicle. A thin cable spools off the rear of the vehicle as it moves. High-bandwidth video returns to the operator. Precise control inputs travel the other direction. There is no radio frequency emission to detect or suppress. You cannot jam a wire. The UGV reaches the objective trench and begins operator-directed action. The operator in the rear cell, 20 kilometers from the contact line, sees through the vehicle's onboard camera. He directs the vehicle to scout firing positions, identify the location of any remaining Russian personnel, and if equipped with a direct fire payload, engage targets. Mission profiles vary. Some operations prioritize area denial and obstacle detonation, clearing the trench before Ukrainian infantry advances. Others use the UGV as a mobile-shaped charge. Others use it as a persistent observation platform, holding a cleared position until human forces can safely occupy it. The engagement timeline in documented operations runs approximately 12 to 18 minutes from UGV landing to position held or cleared. Now put that next to the traditional assault timeline, 30 to 90 minutes of preparation by fires. A breach element moving under suppressive cover. Concentrated personnel risk in the first 40 seconds of exposed movement. After the position is taken, a holding force required immediately to resist Russian counterassault, because the breach element and the holding force are the same soldiers, exhausted and under continued fire. The drone UGV approach compresses the breach phase to near-zero human exposure. The preparation by fires is reduced because the UGV can clear the position from the inside rather than requiring external destruction of overhead cover. The holding force moves up only after the robot confirms the position is clear. They are not the clearing force. They are the occupation force arriving at a prepared site. Ukrainian commanders confirmed to Channel 4 that in sectors where this system has been deployed, the casualty ratio during position seizure operations has measurably improved. They declined to give specific figures, citing operational security, but the directional finding is consistent across multiple independent sources reporting on the summer 2026 operations. How did Ukraine arrive here? That development path is more constrained and more instructive than the public coverage suggests. Most observers assume that Ukraine's edge in unmanned systems comes primarily from Western technology transfer. In this case, that assumption is wrong. The drone UGV delivery concept is almost entirely domestic, the product of Ukraine's Brave One Defense Innovation Program and a network of small engineering teams operating under direct military contracts. Brave One, established in 2023 as a government-operated fast acquisition channel for dual-use military technology, had funded hundreds of projects by 2025, from FPV improvements to counter-drone systems to AI guidance modules. The ground robot concept emerged from a specific tactical problem identified by Ukrainian assault unit commanders in late 2024. After 2 years of trench warfare, Russian defensive engineering had reached a level of sophistication that made traditional assault approaches increasingly costly. Trenches with overhead cover of 2 to 3 logs deep, standard Russian field engineering by 2025, could not be reliably destroyed by FPV drones flying top attack profiles. A direct overhead hit on heavy cover might not penetrate. Artillery could destroy the cover, but also made the trench floor impassable for advancing infantry. What commanders needed was a system that could operate inside the trench, not above it. Here is the obstacle that nearly stopped the program before it started. The delivery drone's payload envelope imposed a hard ceiling, 16 kilograms maximum at operational weight, including battery, payload, and all structural components. Every ground robot system that Ukrainian engineers initially assessed, commercial platforms, repurposed agricultural robots, adapted military designs from allied countries, exceeded that ceiling. The smallest viable tracked platform from existing designs weighed 22 kilograms, 6 kilograms over the limit for the Bober-class airframe to deliver accurately from the altitudes needed for a cushion drop. Engineers had to design from scratch, targeting a final weight that had never been achieved in a combat-capable tracked UGV. They achieved it by stripping every non-essential component, using composite materials for the chassis, and designing the fiber-optic spool housing as a structural element rather than an attachment. The result, under 16 kilograms, tracked, combat-capable, took approximately 14 months from initial concept to first field trial. That timeline is the relevant benchmark. NATO's Robotic Combat Vehicle program has been in formal development since 2019. As of July 2026, it has not deployed a combat-capable system to any operational theater. Ukraine, operating under wartime resource constraints, fielded a working system in 14 months. This seems counterintuitive until you look at the mechanism. Wartime constraint produced faster innovation than peacetime procurement. The reason is direct operational feedback. Ukrainian engineers talk to operators who are using the previous iteration in combat. The gap between prototype and production is weeks, not years. Requirements don't drift because the users are not bureaucrats. They are soldiers who can describe exactly what broke and why. The program worked. The system deployed, and then came the question every Ukrainian defense innovation eventually faces. What does Russia do about it? The obvious Russian response to a remote-controlled ground vehicle would be radio frequency jamming, the same approach that has partially degraded Ukrainian FPV drone effectiveness in some sectors. Russia's Krasuka and Pol-21 electronic warfare complexes and the smaller frontline jammer installations deployed at company level since 2024 can suppress GPS-guided navigation and disrupt standard video links. Against a fiber-optic linked UGV, this approach achieves nothing. The control signal travels down a wire. No electromagnetic emission is involved on the UGV side. There is nothing to jam. The secondary Russian countermeasure is thermal optics and dedicated anti-drone personnel. Russian positions with thermal imaging can detect the delivery drone before it reaches the drop zone. The airframe, at low altitude, has a detectable thermal signature, even against a cold sky. This requires both having thermal equipment in position and having personnel alert enough to identify the specific flight profile of a low-altitude bomber versus an FPV drone, in real time, at night, or in reduced visibility conditions. Russian positions in contested sectors have shown elevated drone threat awareness since late 2025, and open-source footage shows increased use of anti-drone netting over trench positions. Netting can deflect an FPV drone approaching from above. It will not prevent a UGV deployed by parachute or cushion drop from landing inside the position. The third Russian counter is a harder problem: dedicated anti-UGV patrol. Assigning personnel specifically to detect and engage ground robots that may enter a trench position. A soldier with a thermal sight and awareness of the threat can engage a tracked vehicle moving through a trench. But assigning personnel to this role means reducing the defenders available for their primary function. Every person watching for a robot is not watching for infantry or engaging drones. The UGV threat forces a resource allocation problem that did not exist before 2026. The most plausible long-term counter to this system turns out not to be a technology at all. It's a doctrine shift, abandoning the prepared permanent trench as the primary defensive fortification and adopting a more mobile, less predictable defensive posture that denies Ukraine a fixed target to assault via UGV. Russian military tradition has strongly favored prepared defensive positions. Dig in, reinforce, hold. The Ukrainian drone UGV system exploits exactly that preference. A position that Russian engineers spent weeks constructing becomes a liability once a UGV can operate inside it. Whether Russian forces will actually shift doctrine in response is genuinely uncertain. 3 years of evidence suggests that Russian tactical adaptation at company and battalion level has been slower than their doctrine manuals would imply. The institutional weight of established practice is significant. Here is the harder countermeasure scenario, and the one that deserves more attention than it currently receives in public analysis. Open-source tracking of Russian defense technology publications has described, since early 2026, a concept for a specialized anti-UGV loitering munition, a small hovering drone programmed to scan for ground vehicle movement patterns inside trench positions and engage autonomously. Several Russian military technology channels, monitored by Western analysts, have described this concept in general terms. It is at the demonstration stage, not deployed. If fielded at scale, it would force Ukrainian UGV operators into a hide and reposition cycle that could substantially slow operational tempo. The operative word is if. Russian defense production has consistently failed to translate announced capabilities into deployed systems at the pace that combat operations require. The same electronic supply chain constraints that have forced Russian artillery to use commercial integrated circuits also affect every precision guidance system they attempt to produce at scale. A sophisticated anti-UGV loitering munition requires exactly the optics, processors, and navigation hardware that Western export controls have made difficult to source since 2022. We'll say what most defense analysis avoids stating plainly. The development gap between Ukrainian and Russian ground robotic systems in mid-2026 is substantially larger than the symmetry implied by most public coverage. Russia has demonstrated remote-controlled ground vehicles for logistics and engineering tasks. Open-source footage has shown these since 2024. But a logistics robot and a combat UGV, delivered via bomber drone into a contested trench, are separated by years of operational iteration and the kind of feedback loop that only comes from using a system in actual combat. Ukraine has that iteration. Russia does not. This is the unpopular take, and we'll own it. The technological asymmetry in ground robotic systems currently favors Ukraine more decisively than the public conversation reflects, and Russia's announced counter-programs are unlikely to close that gap in the near term. Whether that timeline holds long enough to matter in the current operational phase, that is the question analysts are genuinely divided on. Drop your assessment in the comments, because the range of credible expert views here is wider than on almost any other technical question from the front. Now, what is NATO actually taking from this? The NATO observer picture from Ukrainian operations has shifted significantly since early 2025. Defense attachés from multiple alliance members have reviewed operational reports from drone UGV assaults, and, following the Channel 4 documentary release, the question has moved from defense technology conferences into senior military planning discussions. The doctrine question NATO is now working through centers on a specific framing. Does this technology make dismounted infantry assault obsolete as a concept, or does it change the tools that enable assault while leaving the role of infantry largely intact? The United States Marine Corps already answered a related question in 2020, when it removed all main battle tank battalions from its force structure. The rationale was distributed maritime operations. In the Pacific Theater, heavy armor is a logistical liability that cannot be sustained across the literal distances of a contested island chain. Critics at the time argued the Corps was eliminating a capability it would eventually need. Ukraine's experience has complicated that argument, because what Ukrainian operations have demonstrated is not that heavy armor is irrelevant. It remains the dominant platform for exploitation of success and terrain holding. What the drone UGV evidence shows is that the cost of introducing any conventional force, armored or dismounted, to a contested breach zone without unmanned preparation has become very high. Applied to dismounted infantry, the logic produces a parallel conclusion. Human soldiers can hold terrain. They can exploit success. They can perform the adaptive judgment tasks of ground combat that unmanned systems cannot yet replicate. What the drone UGV packet removes is the requirement for humans to be the first element through a defended breach. The force structure implication is not eliminate infantry, it is eliminate infantry as the breach element. For NATO militaries planning high-intensity conflict against a peer adversary, this represents a significant procurement re-evaluation. The United Kingdom's infantry modernization program includes robotic wingman concepts, but at a development pace that has consistently lagged the operational reality Ukraine is demonstrating. British defense officials acknowledged publicly, following the Channel 4 broadcast, that the timeline for fielding comparable systems in British Army units is measured in years. The same acknowledgement, in various forms, has come from France, Germany, and the Nordic members. The United States Army's Robotic Combat Vehicle program has been in development since 2019. 7 years. As of July 2026, no combat-capable system has been deployed to any operational theater. Ukraine began its UGV delivery program in late 2024. 14 months later, deployed. The gap between what a wartime economy under direct operational pressure can produce and what a peacetime procurement system can field is not a funding gap. It is an institutional gap. And one detail of that gap that tends not to make the briefings, the Ukrainian system cost, at current production estimates, is between $20,000 and $40,000 per UGV. The Robotic Combat Vehicle Development Program has spent considerably more than that per unit across its development cycle, without producing a deployed system. Put yourself in the position of a NATO brigade commander running a force structure review right now. You have a documented Ukrainian example showing 5 operators in a remote cell can substitute for a 15-person breach element, using a system that costs a fraction of what your current infantry equipment package costs to sustain across a career force. The institutional resistance to changing established doctrine around it is where the real friction lives. The next escalation is already visible in the public record, and it closes the gap between where this technology is today and where it is clearly heading. Ukrainian defense technology conferences in spring 2026, combined with statements from the Brave One program, describe coordinated multi-UGV deployment, a single bomber drone releasing 2 or 3 smaller ground vehicles simultaneously, controlled by different operators from the same rear cell. The tactical concept is a simultaneous entry approach, 2 UGVs entering a trench position from different access points at the same moment, preventing Russian personnel from withdrawing to prepared secondary positions before the first vehicle reaches them. The second development is autonomous navigation. Current UGV operations in Ukraine are fully operator-directed. The vehicle responds to inputs from the operator, with no autonomous movement. The fiber-optic link provides the bandwidth for high-quality video and precise control, but it also limits operational range to the length of the cable spool, typically 200 to 300 meters from the landing point. Engineers working on next-generation systems describe a hybrid architecture, fiber-optic control for the breach and clearing phase, transitioning to onboard autonomous navigation using terrain mapping for exploitation of the secured position beyond cable range. Autonomous terminal guidance for a ground vehicle operating in a trench environment is technically harder than for an aerial platform. The terrain is irregular, obstacles are unpredictable, the operating envelope is confined. But the TFL-1 AI guidance module, described in Ukrainian defense reporting as delivering approximately 4 times the engagement accuracy for aerial strike drones, indicates that the underlying AI development work is advancing at a rate that makes autonomous UGV operation a near-term development question, not a long-range aspiration. The third development is production scale, dozens per month currently. The trajectory of FPV production, from hundreds in 2022 to over 100,000 units per month by early 2026, demonstrates what happens when a Ukrainian production ecosystem identifies a system with clear operational value and begins scaling it. The barriers to UGV scale are the fiber-optic cable manufacturing capacity and the precision guidance components for the delivery drone. Both are domestic production problems. Ukraine has been solving both. What this trajectory means for the 2026-2027 operational picture is uncertain in the specifics and clear in the direction. More deployments, more sectors, higher payload capability, extended operating range as autonomous navigation matures. Whether that produces a fundamental shift in Russian defensive doctrine or a technology catch-up from the Russian industrial side is the open variable that no analyst can currently close with confidence. The Russian counter-system concept exists on paper. Whether it reaches the field before Ukrainian deployment reaches battalion-level operations is the timing question. Here is the cold version of where this stands. The breach problem in ground combat has existed since the invention of fortified positions. For a century, the answer was fires, suppression, and human soldiers accepting the exposure risk of the breach in exchange for the tactical value of terrain. Ukraine's drone UGV delivery system is the first deployed technology that credibly substitutes for the human breach element without requiring the human to be present in the contested zone. It works today, in the trench environment of eastern Ukraine, in documented operations confirmed by independent media and on-record military sources. Whether it works at scale, whether countermeasures close the gap, and whether NATO armies can adapt procurement timelines to match what a wartime economy has already fielded, those questions are not settled. The doctrine is being written in real time. What is settled is the direction. Ground combat is moving toward a smaller number of human operators, controlling a larger number of unmanned systems at increasing range. The 5-operator cell that replaced the 15-person breach team is not the end of that trend. It is the beginning. The robots get cheaper every generation. The training pipeline for human soldiers does not. That is the equation every ground force is now working through, with no clean answer yet on the table. Will UGV breach delivery become standard NATO doctrine within 5 years, or will traditional infantry assault hold as the standard because this technology fails to scale? We read every comment. Drop your call below.